RoboPapa.
Hey YouTubers, RoboPapa here, and today what we're going to do is to look a little bit more into the C# function, in particularly a recursive function. So what we'll do, we'll take a look, I'll explain to you what a recursive function is. We'll take an example of the factorial function, and we'll solve it without doing it in a recursive way, and then I'll show that also how we're doing it in a recursive way. So let's go to the computer and we'll start coding. Okay, here we are in the Visual Studio environment, and we can start looking into the recursion function and what it is. So let me delete everything that we did so far, and we'll start like fresh. And also I will increase the font over here, that way it might be a little bit easier to see. So what is a recursion function? A recursion function is basically a function that calls itself, and therefore within that recursion function you have to have a couple of things. One is termination check, so you don't want that function to actually go forever, and then eventually it will use all the memory in the heap. So you want to make sure that you're terminating your function. The other thing is that you need to think about the function as it's doing the same thing. No matter how many times you call it, it's just doing the same thing. So let's take an example, and I think it will be much clearer like that. So the example that we'll do today is actually the factorial operation in mathematics. The factorial itself is basically if you have a number n, if you have the number n and you want to calculate the factorial of it, what that means is you're actually taking the number n times the n minus 1 factorial. So if we'll put that into an example, if you wanted to have, for example, the 3 factorial, that will be equal to 3 times the 2 factorial. But the 2 factorial is actually 2 times 1 factorial, and our 1 factorial is actually 1 times 1. And that's our stopping, in a way, our stopping condition. Also to note is that actually 0 factorial is still equal to 1. That's something that we'll need to take care of. So I'll show you over here how to do that with the regular loop, and then we can convert that into a recursion function. So let's start by actually doing certain things. So in our main function, this is our main function over here, and that's what's running. If you need the reminder, you can look at my previous videos on the C#, and I post a link again on the screen, that way you can go there. So we'll start over here by declaring a string, and that string will be what the user is actually input. We also will declare like an exit boolean, and we'll initialize it to false. The idea behind that is over here is that the program will continue on until the user will type a certain keyword. In our case it will be Q, to exit the program, and until it doesn't do that, it will continue asking for a new number, and it will calculate the factorial. So we will do a do loop, and we'll, as long as it's not exit, we will do that loop. So as long as exit is false, the loop will continue. And what we will do here is we will clear our console, which means it will erase everything that we did so far. And let's write a line and say over here that we need to enter something, right? So we need to enter a number that it's greater than 0. So to calculate factorial, or let's say Q for us to exit. So Q Q to exit. So that will output into the screen that particular text. That way our user will know what they need to do. Then we'll write it over here, not a line, but just write, and we'll say your entry. That way the user will know that this is what they need to, where they need to input this. Then we'll need to read from the console, and just like there's a write and write line, the console library over here, the .NET, gives us also the read option. So what we need to do is line equal to console.read line. And the reason we're deciding to read line instead of read key is because I can put a factorial of 2 digits, and read key will only read a single digit or a single character. So that's why we want to read a line over here. Then we'll declare the number equal to 0. And we'll need to check to see if what we actually entered is according to the qualifications. For example, a number that it's greater or equal to 0, or Q for exit. Anything else will count as something that we cannot process, and we'll just skip it and we'll move to the next iteration. So we'll do int.tryParse. So there's a function within the int spectrum of .NET that takes a string and it will try to convert that to an integer. And if it doesn't succeed, so if the string is not a valid integer or there's an overflow, stuff like that, the tryParse will not return true and fail. And what it's requiring, as you can see over here, is requiring a string, and we will just use the out int result. And I know out is not, we didn't touch it yet, but in a nutshell, you passing this to a function, and the function will assign a value to it. That way you can reference that later. So we'll pass the line because that's our input, and we'll do out number because that's what we declared over here as the number, which means that the tryParse will put our number over here. So if the tryParse will be successful, we still need to make sure that the number is greater than 0, or greater or equal to 0. So we'll do an AND number is greater than -1, because -1 is not a valid number for Factorial. The minimum number you can use for Factorial is 0. So if the number is a real number, a positive number, and it's greater than -1, then we'll do something over here. And what we'll do is we'll just write a line and we'll say something Factorial, so that will be our input, the user input is equal to this. And that particular syntax in the right line is kind of like string format, and it will format this string and it says this is the place 0, this is the place 1, and now I'm passing in what parameters we want. So 1, we know that the first one is the number, and the next thing, so it will say number factorial. So if we put here 3, it will be 3 factorial equal to something. Well, that something will be our function, so we'll call it factorial, and we'll pass in a number. And the factorial function is still not declared, that's why it's red, but we will get to that in a second. For now, we can actually write the function header, so it will be static, and the reason it needs to be static is because our main is static. So we're just going to use static over here, and it's returning an int because that's what Factorial does, and we'll just call it a number. So now you can see this one is no longer red, and we have the header of the function. We know the name is Factorial, it will accept an integer value, and it will return an integer value. Okay, so now we output to the user what they enter as the number and what is the result. That's in the case of successful. However, it still can fail, and the failing can be 2. One is it's invalid. We know that it's invalid int. So, but we don't know what is the reason that it's invalid. Is it because I enter A, B, C, D, or did I enter a negative number? So we need to check for that. And also we need to make sure that the user didn't enter a queue which he wants to exit. So for now, let's try and we'll compare the input with our termination of the function. So we'll use the string.compare, and all it does, it's taking two strings and comparing them. So the first string will be our line, the next string will be our queue, but the user can actually enter either lowercase q or uppercase q, and we don't care because both of them do the same thing. So we'll use the string comparison over here. So we'll use the culture ignore case, and that will take either uppercase q and lowercase q, and it doesn't matter for that comparison. And the comparison returning an integer. 0 it's if they equal, -1 if the second is greater, and 1 is if the first is greater. And over here, all we care about to make sure is that if it's equal to 0. If it's equal to 0, we know the user wanted to actually exit. So what we'll do over here, we'll just output to the screen that you typed Q, program will exit now. And then to exit, we'll just say exit equal true. Therefore, our while loop over here, it will be not true, which is false, and therefore it will exit it. And then the last else is if anything that they entered, if it was not Q or was not a valid number. So therefore, let's write down to the screen that they enter an invalid input parameter. Okay. Now, because we're clearing over here the console, that means that everything will disappear. So we should actually kind of like stop the program for, let's say, half a second, and that will give our user the option to see what they did. So if we'll do thread, and thread is part of the system .threading, and that will tell us this is the current thread. And we could do sleep, and it's in millisecond, so we'll give it 500 milliseconds. So assuming that this factorial function is already built, and we know that it gives us back a factorial number, let's go through over here real quick, and we'll see we're getting a line, and we're having the exit parameter. We're clearing the screen, and we outputting something to the user, that way they know what they need to do. Then we're waiting for the user's input. When the user input is coming in, we'll try to parse it as an integer and make sure that the integer is bigger than or equal to 0. If it is, we'll call the factorial function, which will calculate our factorial. And we'll output a nice formatted string, and therefore after that we'll just wait for 500 milliseconds. If they didn't enter a valid number, we'll try to qualify it for it if they wanted to exit or not. So we will try to compare that with a queue. And we're ignoring the case, that way lowercase or uppercase q will qualify. And if it's equal to 0, because it's the compare, that means that they're equal, and therefore we'll exit. Otherwise, we'll show the user a generic error that it's not a valid number. In either case of these, we'll wait for 500 milliseconds, and then we'll exit if they typed q, or we'll come back here and start over again. So now to the fun part is the factorial. So as you remember, I said that n factorial is n times n minus 1 factorial, which means that if we're taking the number 3 factorial, we need to do 3 times 2 factorial, and the 2 factorial is 2 times 1 factorial, and the 1 factorial is 1 times 1. So really, 3 factorial is 3 times 2 times 1. So if we try to do that in a for loop, or in any loop, what we can do is we can declare a total, and we'll say that it's equal to 1. We can do an index, that way we'll know, and we can start it from 2, And the reason we're starting from 2 is because 2 factorial is 2 times 1. Therefore, like, we don't need to do like the 1 factorial because it's redundant. Then we'll just do while the index is less than or equal to the number. So if we pass 3 factorial, so it will start with 2, we'll go to 3, and we'll calculate that. If we're sending 2 or if we're sending 1, then it will just will not even enter. And what we'll do is we'll say total is times equal the index. So for example, 1 times 2, it's actually 2, and that's the 2 factorial. And if we send 3, it will start with 2. So 1 times 2 is 2, and we'll need to increment the index. So now our index will be 3, and then 3 times 2, because total now is 2, will give us 6, and then it will exit. And then what we need to do is just return total. So that's how you do the factorial with just a loop. So let's try that, and let's run this. So here's our message, and let's say I entered an invalid number. It gives us the message, refresh the console and output again. If we enter 3 factorial, so we enter 3, it says to us the 3 factorial was 6. Let me do it again. If we'll do 2, it's actually 2. If we'll do 1, it's give us 1. And 0, if we'll enter 0, should still be 1. And then Q is actually exit. So that works. And that's how we do the factorial with just a loop. But let's take this now and convert that into a recursion. That way you can see what it is. So as you remember, like I said, in the recursion, it's the same code that runs for any call. And the thing that we need to remember in recursion is to have a stopping check. So in our stopping check, it will actually be that if the number is less than 3, now we're assuming that the number over here is 0 and above. So if the number is less than 3, we can actually return, and what we want to return over here is the number, except that when it's 0. When it's 0, still we want to return 0. We want to return 1, because 0 factorial is 1. So what we will do, we call the math function max, and that will be between the number and 1. So when number, for example, is 2, it will return 2. When the number is 1, it will return 1. If the number is 0, though, then it will return 1 because 1 is bigger than 0. So that's our stopping for the recursion. And now all we need to do, as you remember over here, our mathematical was that n factorial is actually n times n minus 1 factorial. So what we can do is over here say a return of the number times factorial of number minus 1. So that will be as if we did that the n factorial will be equal to n times n minus 1 factorial. And that's really our recursion. We're calling the same function, the factorial, again and again until we actually hitting our breaking point, which is this one. So here's the code, and let's see if we can, if it works. So we'll run this, and let's try 0. So 0 factorial was 1. Try 1. 1 is 1. 2 should be 2. 3 should be 6 because it's 3 times 2 times 1, which is 6. 4 is 24 because we know that 3 factorial is 6. So 4 times 6 is 24. 5 factorial will be 5 times 4 factorial. 4 factorial we already discovered it's 24. Therefore 5 factorial will be 120. So it seems like it's working with no problem. So here's the code. Basically 3 lines of code and you're done, versus declaring variables and making sure that the calculations is right and the stopping point is right, etc. So we have over here somewhere around 7 lines of code versus 3, and that's just a simple example, but it still worked the same way. One thing though to remember with recursions, it's using the heap memory, which means that if you call it too much, then you might get like out of memory exception. Let's see if we can actually get to that. Let me put like a big number. I don't know. Let's try 100,000 or yeah. Let's try 100,000. See if that will. You can see now that it's actually stopped because it cannot continue on, and that exceeded the amount of memory in the heap itself. So that's just one thing to remember with recursion, is that it cannot continue forever because it's using the heap to remember where it actually was calling and where it needs to go back. So that's basically the recursion function. I just wanted to touch with that example to explain a little bit more about functions. Next episode, we actually start touching about classes. As you can see over here, there's a class myMain. So what are classes, what are objects, and the things around them, and how can you use them. So don't forget to subscribe and like, that way you can get the notifications with your subscription. And it's free, so it doesn't cost you anything. If you have any questions, please leave a comment below, and I'll answer you to my best knowledge. Until next time, thanks guys.